Hello there, my mate Vince here, and in this video today we're going to be looking at a PlayStation 5. This is the digital edition, so there's no disk drive on this one here. It was sent into my PO box by a Patreon called Gavin, and he said that he got it cheap off of friends, and originally it had a 2-second blod, a blue light of death, but then it turned into no power whatsoever. So he thought he'd send it to me just in case it could be fixed. He's fully aware that it will probably get sent back to him fully broken, but he's happy to strip it down and sell it for parts. So when I plug power into the back, this lead is perfect. I plug it in here and it does nothing. Doesn't make a beep, no lights, no crackle, nothing. Completely and utterly dead. So let's take it over to, I'm not sure what colour mat I'm going to use today, and I don't know, let's measure a few voltages. First of all, I'm going to check the power supply, see if maybe we have 12 volts coming out of it, and then what would be nice is if there was a short on the board somewhere, but Gavin has had a look at it and he couldn't find anything obvious. But you never know, I might have more luck. I've opted for the new blue, why not? Now, which way is it? This one here? This is where I have to undo about 30 million screws. Oh, there's something rattling. Two little tabs here fit in here, so you just lift them up and push them back. Right, okay. Looking in here, the USB ports look alright. HDMI port has had a bash here, but I think the port itself looks okay. Right now, so I've got to undo, I think, all the screws everywhere, haven't I? Let's get started. Oh, I've just realised it must have been Gavin. He's put a little blue mark on every single place where the screws go. That's quite clever, because some of these holes here, you don't put the screws in. It would be other screws that go in these ones. So yeah, that's going to help me when I put it back together. Okay, I can't see any water damage or anything there. Now, just a quick scan across here. I can't see any problem there. Let's see if we have 12 volts, because this is the 12 volt connector from the power supply. So let's plug this in here. And we'll measure for 12 volts, see if we've got anything. Right, plugging it in now. No, we don't have anything there. Ooh, okay. Should we see, let's unplug it. Should we see if we got a short there? Or is it going to be confused because it's got the power supply plugged in? Right, so wait until the voltage goes. Right, voltage is gone. Oh no. Oh, there's no short. Oh, I wanted a short. That's annoying. Right, okay. Well, you never know, it could be a power supply problem. It is possible. Okay, I'm just jumping in whilst editing. There was actually a short here, I just didn't press down hard enough on my leads. These two blobs of solder do have a bit of a coating on them, and you need to scrape through that to make a good contact. So if I'd pressed down harder on the leads, there would have been a short. So it's certainly not open. There is a short on this main incoming rail. Oh, hold on, those pins don't look right. Maybe that's why it's not turning on. Is that feeding? Oh no, that's that board here. That's for the USB and stuff. If you have a look at these pins, can you see they've kind of been pushed back a little? Well, I'm hoping they'll make contact, because it looks like, I don't know, it kind of looks shiny up to there, and they're still shiny up to there. So as long as these are not shorting, I think they'll be okay. Right, there we go. Doesn't seem to be much liquid metal on it. Seems to be quite a lot of marks here. Okay. Do you know what? I actually don't own any liquid metal. Oh yeah, look. Oh, hold on. What the hell is that? Oh my word. What is that? Oh, it's all a bit of a mess down here. Look. Right, 1 second. I think this has had a lot of liquid metal around the place. Look at this thing here. Look at that there. And what's going on there? Is that a capacitor? Where's, oh, that capacitor's come off there. Ah, right, okay, and this is all burnt here. That's another capacitor there. Oh, maybe that capacitor's from here. Yeah, it looks like, I think work has been done here. But then look at the state of that thing. I mean, this is on one of the massive rails. Look at the size of that there. What's going on here? Right, okay, let's first of all, let's not worry about this. I'm going to say that I don't think this is going to be fixable. I'm not sure how much actual, I don't know if this is all natural or whether, I mean, maybe something has just blown up. But it just looks a bit, I don't know, everything looks a bit dirty, doesn't it? Not sure what's going on. Right, let's plug in the power supply, see if we have 12 volts here, then we'll know whether or not the power supply is working. My worry is, you see, is that it was a blue light of death, 2 seconds, and then it became a no power issue. So I don't really want to, I don't know, for example, I could fix a no power issue, which could be sorting out all that mess up the top corner of the board, and it still might have a blue light of death that maybe is not repairable. Let's see if we've got anything going on in here. Okay, 12 volts, so we have got the power supply itself is working. So to begin with, we can see that we have a blown up coil and also a track that needs repairing. So let's get the hot air on this and remove that coil. It's going to take 500 degrees Celsius and a lot of airflow because this board's really thick, so it sucks away a lot of the heat. But let's start off by removing the coil anyway, and then we'll worry about what's what. Right, solder's starting to turn. Starting to lift on that side. Here we go, here it comes. Excellent. See, my worry is with this liquid metal, is it going to add a weird resistance? I know a big blob would short, but if it's just kind of smeared everywhere, like for example, look down here. Yeah, watch this. So this is a clean cotton bud. And now put a bit of IPA on that, move it around here, and look at that, you see? So I wonder, would that kind of affect resistances if it was just a little bit smeared everywhere? Because you know, all these things are unpopulated here, but if there was something that's going to cause resistance between them smeared over it, you know, that could affect it, couldn't it? I mean, look at that. Right, okay. I'm going to get another board out and see if I can get some reading difference between them. So I've got the other board out here. I just want to see if it's the same. So this one is EDM010. Excellent, it is. EDM010. Right now, so what am I looking at up here? Oh, also, look, this is interesting. Do you remember I said there wasn't a short on here? Well, that's because it wasn't making a good contact at the back. Look. So here, let's just go to continuity just to make it easier. But look, it's not showing anything. It's just because it's a bit crusty. If I was to go here and then here, you can see it is. So if I was to pierce through all the crust, then it would. There you go. It's well crusty. There you go. So there was always a short on that rail there. Well, actually, I say that. Let's see it compared to this one here. So let's go to ohms. And let's go straight onto here, see what we're getting. So we have got a short on the 12 volt rail. Because look at that, that's 20,000 ohms. This board here isn't working. But from memory, it did have voltages on it. And that's a 4 ohm short. Right, okay. So we have got a short there. So now, this is that little coil thing going on there. And we have got a capacitor going up to here. So now, I mean, look at the colour difference on the board. Look how clean this is. And look how dirty this is from all the liquid metal everywhere. Looks like it's had an explosion. So what is causing, I've got a short on the 12 volt line, but it could be anywhere. So why don't I just take off the components here and then I can have a look on the pads, because the fault might be in this area, because we've definitely had, I mean, something's caused this to blow off here, isn't it? But look, this is now separated from here. So nothing here is actually testing short, I don't think. That's going to be the grounds. Yeah, so by taking this coil off, I've kind of isolated this bit here, haven't I? I tell you what we do. Why don't we take off that tiny little fuse just here? Yeah, so let me go to continuity. And then you see, it will tell me if it's this little section here, won't it? So if you have a look here. Right now, we have a short between here and here, yeah? Which means we've got a short here. But if I take off this tiny little fuse, it will then tell me, or maybe not a fuse, but do you know what? That is the fuse there, isn't it? Yeah. If I take off that, that will then tell me if which side it's coming from. Because there's no point in taking off these components here if the short's from here. Let's do that. Right now, so let's see what's shorted. That's bad news. There. So it's not here, so you can see that none of these caps are actually shorted. So it's something here. Now, where does that go to? So the reason these were shorted here is because the resistor was putting the short through onto here. Right, okay, let's just see what's on the other side of the board to that. And that's shorted there. Maybe that's part of it, but that's not going anywhere. So I don't know where that's going to on the board, you see. Right, I'll tell you what we'll do. Let's zoom out and let's see if we have any other shorts on either side of the board. Right, I'm not really sure if this video is going to make much sense, but basically the main power rail on the PlayStation 5 is the 12 volt line, and then the other power rails will come from that 12 volt line, so 5 volt, 3.3 volt, 1.8 volt, etc. Now, the power supply is giving out 12 volts. It's just that when it's connected to the board, it's not giving out anything because there's a short on the 12 volt line, meaning that there's some fault somewhere which is bringing the 12 volt down to ground, and that's why we haven't got the 12 volt, because it's short into ground. So what I'm trying to do is find out where the short to ground is, but often that's easier said than done. But that's what I'm trying to do in this part of the video now. I'm trying to find out where the 12 volts are on this board, and it might help me pinpoint where the fault's coming from. Right, so it looks like this here is connected to here, which is connected to here. Yeah, and they're all connected on this board as well. So, for example, here and here. But look, none of these are connected to ground on here, but they are on my one. And they're all massive rails there. So I'm going to solder a wire onto the 12 volt rail, and let's see if the FLIR cam will pick anything up if we pump 1 volt into it from my bench power supply at high amps. So I might put in 1 volt at, for example, like 3 or 4 amps, and then we'll see if anything's getting warm. Got to be careful with the reflections. Oh no, well hopefully that's reflections, that's the main APU. I'm worried. Right, okay, let's flip it over. Maybe something will show up on this side. There's definitely heat coming from the middle here. This is worrying. There's no heat spots on the board, only in the middle here. Oh, come on. Right, well, if you look there, the only thing that's getting warm is the main chip, the main APU in the middle here, which is worrying for me. Yeah, I can feel just ever so slight warmth, but it's not, it's not hot. Yeah, 30 degrees. Right, okay. Well, we got a short there, and there's nothing coming up on the board as short. So, I mean, what else can I do? Well, unless I suppose we were to isolate it from here, I suppose I could take off. This coil here, and then remind you, it's going to be shorting through this coil here to these two, isn't it? I mean, could it be possible that something's shorted in here? Let's kill power. Let me just zoom in a second. Right, that's all good. Do you reckon there's anything under there? I just want to peel it back a bit, just in case a bit of liquid metal got in there. I don't think it has. I think it looks quite neat. I don't want to peel this off completely because I haven't got any of these, you see, to put back on. No, I can't see any shorts on those capacitors in there. I believe they're all good. Right, at this moment in time, I think it's a faulty APU because there's nothing else getting warm. But I don't really want to say that because it just sounds like a bit of a cop-out, and it'd be an annoying end to a video because it's inconclusive. But something very bad has happened on the 12-volt rail. It's shorted. So I'm thinking it's sent voltage down to a lower voltage rail. Look at that. That's another bit of liquid metal there. I'm thinking it's sent voltage down to a lower voltage rail and fried that. The thing is, what are the odds of it going to the APU? You know, the APU is going to be really low, like 1.8 volts or something. So you think it would have fried something on like a 5-volt rail or a 3.3 volt rail. But saying that, this does look like it's feeding here, doesn't it? All these different ones here, different power supplies feeding this. And this is from the 12-volt rail, it looks like. So yeah, maybe it is. So what I'm going to do is, because I don't right now, if I'm honest with you, know how to take it any further, because I've put voltage into it, and the only thing I can see heating up is this. So I don't think I've put abnormal voltages into here, but this was definitely the only thing heating up. I think I'm going to relax for a couple of hours. I'm going to maybe go onto Google, maybe the coder's got some videos. I'm going to type in PlayStation 5 short on 12-volt rail, and maybe people far more knowledgeable than myself will have an idea of what it is, or they might have videos on it, in which case then I can kind of copy their fault finding process and we might get somewhere. So yeah, right now this has kind of beaten me in its own right. I'm going to have to use the help of other people, and hopefully I can find something online that might help me. I mean, there's just liquid metal everywhere. So yeah, I mean, maybe some liquid metal's actually gone under here, because remember, I've seen it once it's been cleaned up, because there's going to be hundreds if not thousands of balls under this, and there could be a drop of liquid metal in there. It is possible, because you know what I mean, there's been a serious cleanup done. Look, see, look at that. Yeah, so we got that one there compared to here. Look at the difference. So it looks like kind of liquid metal got absolutely everywhere. So it could have easily gone under the BGA chips. So I might be fighting a losing battle on this one. Anyway, I'm going to relax for a little bit. My son's already made me a nice coffee from the DeLonghi coffee machine that I fixed in another video. And I'm going to sit there and watch, hopefully, the coder. And hopefully he'll have some answers. Alright, I'm enjoying this. I'm watching Decoder. This reminds me years ago of trying to fix like an Xbox One S, and I was watching Andrew Paul like talking, you know, going through it live when he's doing it. So basically, Coder's got a video here. This is, his name's Phil, and it says, can I fix a PlayStation 5 with a shorted 12 volt rail, no power, PS5 repair? He's man of PlayStation 5s and Nintendo Switches, any sort of modern console. And basically, same situation as me. He was going through various different ohms testing on this side to test different rails. Was it this side? Yeah, just to make sure there wasn't shorts on like the 5 volt and the 3 volt, 3.3 and stuff like that. There's not. Now, what he's saying is that on the 12 volt, it could be a fault with the APU. Fingers crossed mine isn't. Or it could be all these MOSFETs down here. So the stage I've got to in the video is where he's taken off. Annoyingly, his board is different. I'm trying to see what his board is. I think his must be a different edition. So I'm not sure if his is the one after this. But what he did is, he took off, I think it was... Yeah, I'm looking at it now. He's taken off this one here, and what that does is then his 12 volt volt short has disappeared because it's on the phases. So I think I should do that now, but it looks like I need to take off this one and this one. Here it comes. Excellent. Right, you won't be able to hear the beep, but you might be able to see it. Ah, interesting. Well, there's no short this side now. But there's a short this side. There we go. To be fair, that came off a lot better than I thought. I'm going to let the air cool down so you can hear me, and then we'll test this one when that's gone off. And peace and quiet. Right, here goes. Ah, full short there, but not here. Yes, I think that means I need to watch Decoder's video. I think that means that the APU is going to be okay, surely, because that there must be going on to feed this. Right, so we still have a full short here. Let's just go straight on to resistance. Yeah, there you go, a 2 ohm short. Result. Okay, onwards with the Coder video, because I still don't know where to take it from here. But that's great news. So if I was to put voltage into it now, 1 second, no, let's try to do this ourselves a minute. If I was to put voltage into it now, we shouldn't be getting heat in here because it's no longer connected to 1 volt. And let's see what's happening. There and here. And again, yeah, 1 volt at 0.8 of an amp. Now, would anything be getting warm now? Remember, there's already a lot of heat in this part of the board here. Yeah, you can see all the heat here. Let's see if there's anything else getting warm. At least this is cool now. The APU's cool. That's still hot anyway. Right, I can't see anything. Let's go to this side. It's already heating the board there. Well, whatever it is, it's swallowing up that energy quite nicely without actually showing anything. I hope it's not in the board itself. You know where it kind of blew up here? I hope there isn't a fault in the layers up here. In here somewhere. Let's carry on watching the coder, see what his next steps are. Right, on Coder's video, it was basically one of the MOSFETs under here. But he had a short on this side and I haven't. My short is on this side, isn't it? And check this out. If I go here, on, you know, on the ones that's shorted, yeah, we know that it's over here. And we know that it's, where else is it? It's up here as well, listen. Yeah, it's coming up here. Now, on this one, that is still coming up here, so that must be on the 12 volt rail. Bearing in mind, I know this one isn't working either, but look, if I go onto ground, can you see, you know, it shouldn't be coming up there. So let's zoom in. I'm thinking it could also be this chip here as well, because look, again, 12 volt here, you know, it's coming up here. So maybe this is on this side, if this is controlling all the MOSFETs and stuff. Maybe, not too sure. So rather than taking that off, because that looks more difficult, I'm wondering if it's something here that could be causing it, because it's both linked. At least I might be able to narrow it down a bit more. So I wonder, is the 12 volt coming up here? If I was to remove this, this is ground anyway, so it could be, I wonder, could it be a MOSFET that's faulty, or could it be one of these caps? Mind you, nothing's heating up. Let's remove this one here, because then it might, if it comes up here and it's not coming up here, I've at least isolated this part of the circuit, haven't I? Well, if I still have a short here, then it might, the short might disappear from down here then. Let's take this component off. Right, so let's have a listen. Just to ground. Interesting. Right, so it's no longer on here, yeah? But it's here. So we still have a short on the 12 volt rail. Yes, we do. Okay. Now, should I take this chip off here and see what's happening? Yes, I should, because I'm starting to run out of components to take off to isolate different parts of the board, but Sod's Law will always dictate that it will always be the last thing you take off which will be the faulty one. Never the first one, always the last. Right, now, let's see if it's still shorted here. No, you are. Oh, you got my hopes up there. You are. Oh man. So we still got a short on the 12 volt rail. The thing is, we've got 12 volt rail everywhere, haven't we? I mean, could it not be over here as well? This over here looks like a 12 volt rail. Let's have a look on the board, this one here. Right, so on the 12 volt here, it's 12 volt, so it could be something along here. Let's put a short on it. Nothing, nothing. Here, so this is 12 volt, and this is 12 volt, so the problem could be across here somewhere. That's the problem when it's not heating up. How do I isolate them? By taking off the MOSFETs? Or by taking off these? No, it's not these, is it? No, so I'd have to take off the MOSFETs. Right, there's that. There's probably 12 volts everywhere. We know that's 12 volts already there. This is also 12 volts here, so it could be this MOSFET that's faulty on the other one. I'm going to end up taking apart most of the board. It's a real shame that the thermal cam's not showing anything. It probably would if I went higher on the voltage, but I'm just scared to do that. The reason I don't want to do that is because the APU might run on 1 volt, and if I put 3 or 4 volts in there, then sure, it might be enough to show up a faulty MOSFET, but it might also put 3 or 4 volts into the APU. It's not designed to run on that, so I might end up burning out the APU, even if the fault is on a MOSFET. That's why I don't want to go higher than 1 volt on the bench power supply when I'm using the thermal cam. But unfortunately, at that low voltage, even with the high amps, nothing is getting warm apart from the APU. Right, I think we're going to have to, let's take off this MOSFET, this one and see what, see if that makes any difference. Right, still got a short. Oh my god. Wow. Short's gone. Hold on. Short's gone. No way, the short's gone. Right, let's put this MOSFET back here. No, there's no point. So, 12 volt short has gone. I know you can't hear me. Look at that. Look at that. Wow, wow, wow. So it's something up here, which is not going to be good, because I think they're the ones feeding this. In fact, this was the problem I had on one of the other boards. And I think people agreed it was the APU in that instance. Remember this one? The sick PS5? Spent a lot of effort drawing that. And if you have a look here, do you remember we had a blown MOSFET that shorted right deep into the board? And basically, I think people agreed that that then put the 12 volts into this and burnt that out. But also, there was a USB problem on this one, I think, that was shorted. And it could have also been that burnt this out. Right, so let's zoom in this area, because the short has now gone. So there's going to be something around here which is still putting the short on. So 12 volt is in this bit here. So does that suggest that that MOSFET is faulty? 1 second now. Let's see if we've got a difference between the MOSFETs. And that will tell us, won't it? So this is the one that the fault went away when I took it off. Let's see what's happening. Have we got a short between here and here? No. Have we got here? No. Have we got it here? Should we have it here? Right, so we've got a short there, there, and here. So they're all shorting. Ooh. Oh, they are. But them they're not. Those two are not. Oh, maybe it is a faulty MOSFET unless it's different. Right, 38168. 38168. So they are behaving differently unless, of course, it's latched on. Right, so that's definitely not shorting on them two, but it is these two, but not them two. And these two are not shorting to each other. Right. These are all shorting. Okay, well, let's see what that corresponds to on the board. So that means then that these two here are short into these two, which they look like some sort of gate. Maybe it is as simple as that. Okay, I'll tell you what I'm going to do. See, I'm just worried because we have, we have a short here. But what's confusing is, you see, we're going to have low impedance or whatever because this is feeding the chip. So, for example, 3 ohms is probably completely normal on here on a fully working one. But anyway, we found a problem with the MOSFET. So let's put the MOSFET, let's nick the MOSFET from here, this one here, and let's put it on here, and then we'll see if it starts behaving differently. So I'm going to put a good MOSFET on. I think it's a good MOSFET. I mean, I don't really know what the fault was on the other board. I think it was an APU problem, but we're going to put the MOSFET on from the donor board and hope that it works. Also, I need to put the other MOSFET on. I need to put a new coil on. I need to repair the track that was damaged, and also the chip I swap over as well. And I need to put the other chip on and the other 2 coils. Oh, sorry, and another coil in the top left of the board as well. So there's lots to put back on. and then yeah, we'll see if it starts working. While I'm doing that now, obviously I'm fast forwarding it through all, otherwise you'll be watching me for the next 3 hours. I'll give a shout out to the My Mate Vince Massive. The members are kitdigital.com, Kip Hakes and Max Rokotansky, Having Fun Repairs, Chris Seal, Felipe at MrKeeves.com, DJ VG, Pixie, Robert from Timsey's Auto Air, Anthony Dean, Bazza2, Russ Melanson, Gaspar Heller, Ricard Bergland, Jacob Colpin, Soul Reaver 555 and Lucas Scott. So a massive thanks to each and every one of you. Right, let me just show you that the board is not short anymore, and then we can put it back together and test it on the telly, see what it does. Sorry, also forgot to mention that I replaced all the capacitors that were somehow missing from the board when I got it as well. Right now, fantastic, look at that, it's in the meg ohms. Yeah. Brilliant, not beeping at all. And that is that one there, and this one is ground. There. Right, okay. Fantastic. So now I need to kind of put it roughly back together, don't I? And see what it's doing. I actually don't think this is going to work. So I put it back together and used some IPA just to try to wipe away some of the never-ending liquid metal which is just everywhere. Right, I think that is enough to test, is it not? Yeah, it should be. Fan spins. Right, okay, let's bring it over to the TV and see what it's going to do. Imagine if it works. Okay, here goes. I'm on HDMI 1 on the TV. Let's plug in this lead here. Now, I'm fully expecting it not to work, but for some reason, I'm getting my hopes up, which is dangerous because it's going to lead to disappointment. Right, that's that there. Let's plug it in. Hopefully it doesn't explode. Ready? We're plugged in. Okay. Please give me some kind of beep. Yes. Fan spin. Blue. Back to the original fault. Ah, annoying. Oh. So that was the original fault when Gavin got it. And now it's not coming on. Oh, disappointed. Right, I'm not going to give up just yet. I should give up because it's eating away a lot of my time, but I just want to double check the power supply. I'm going to put a different power supply in it. I know the old one is measuring 12 volts, but just in case when it's under load, it then drops. So I'm going to put in another power supply, and if it does the same thing, then we can pretty much eliminate a power supply fault. I'm just going to try another power supply, just in case. You never know, when it's under load, you might not be happy. So, plug it in. Plug it in now. Here we go. Ready? Come on. No. Still the 2 seconds blue light of death. Right, okay, so it's definitely not the power supply. And then it doesn't come on, and then it comes on again. There we go. Strange, isn't it? So I fixed the fault where it was completely dead, but now we're back to the original problem when Gavin got it, which is the 2 second blue light of death. So I'm going to Google this 2 second blue light of death because maybe it's really common and maybe it's something that can't be fixed. If everyone says it's APU, then at least there's a finish to this video. Right, okay, I've been watching YouTube videos and Phil Decoder did a stream. It was about 4 hours long, I just skipped through it. But basically he had the same problem here, 2 second blue light, and then I think the next time we turn it on there'll be nothing. Turn it on again, 2 second blue light, and basically he went through everything, and it ended up being the HDMI encoder, which is on the opposite side of the board here. And if you have a look, it looks like something's a bit weird has happened here, like it's been dropped or something's happened to this point here. Also, other people are saying there should be 1.8 volts up here, and there's not. If I go here, there should be 1.8 volts, and look at my meter. You can see that there is nothing. And yet we have loads of other rails, so if I was to go here, you will see 3.3. If I was to go here, you see 5. So I've got loads of rails now, but I haven't got the 1.8, which should be here. So we're missing that rail. So I think I'm going to try to take off the encoder. Apparently, these don't turn on with a faulty encoder, or if you had the encoder missing. So you'd think it would still turn on, it just wouldn't display, but no, it doesn't actually turn on, which is quite interesting. Also, sorry, what I didn't show is, apparently Phil also said in that video, it's very common to have APU problems with the two light flashing deaf. And remember, we did have the faulty MOSFET here, so I think it's probably put 12 volts through into the APU. But before I give up completely, I'm going to take off the encoder, put an encoder on from another board. Again, I don't know if these are good encoders or not, but let's see if it behaves any differently. I did try putting pressure down on this, and it's not making any difference. In fact, would I have to put pressure down on the other side, or would... No, by pushing it down on here, it should then put it down on the other side. I did it when this was still attached. I put a load of pressure down here, and it was still exactly the same. I've tried it with this disconnected as well, just in case this was putting some weird short, because these are a little bit bashed up here, but it didn't make a difference. Right, so that there is the encoder. In fact, actually, before we do that, let's have a look at the HDMI port. Hold on a minute, this HDMI port's not on. No, we got a loose pin there. These pins are loose. I didn't realise there was work done on here. Right, okay. Oh dearie me. Thing is, if it didn't recognise the HDMI port, it's not going to give a 2-second blue light, you know what I mean? Because it doesn't know, these are just pins, there's no circuitry in the HDMI. Lots of these are not connected. Also, I think there should be a little capacitor there. And, sorry, I've just noticed as well that these are empty here, aren't they? These are empty. Right, okay. Right, let me get another board and see if I can find out what's going on here. I've now shorted this pin here, but that wasn't shorted originally. Right, I'm just going to go to diode test, and I'm just going to see if I can see any difference between this board. Again, it's still a faulty board, but this area here looks in really good condition. So I'm going to be putting the red probe to ground, and it's a shame I haven't got two crocodile clips. I could just link these two up here, and then it would save me having to keep swapping the probe. Anyway, I'll memorise some of the readings. In this bit here, I got rid of the shorts on the HDMI port. I haven't sorted out the port. It's still loose, it's still not connected, but there's no legs touching anywhere. So the PlayStation 5 itself won't know that the HDMI port is not connected. Obviously, it's not going to display on the TV, but it should still turn on. I'm just getting diode readings around the encoder chip, just in case it might verify before swapping them over that one is testing differently than the other between the good board and the bad board. When I say good board, it's a donor board. It's not a good board, but it's a better board than Gavin's board. Right, okay, they're roughly the same as each other. Do you know what? I'm not going to waste time going across the whole board there. I'm going to swap that chip over just to see if it does make any difference or not. I've kind of convinced myself now it's going to be an APU problem, purely because of this shorted MOSFET that was on the 12 volt rail. So yeah, I think it's put 12 volts straight into this. Basically, if I swap this over and the blue light, 2-second blue light goes away, then of course I'll deal with the HDMI port. But there's no point in messing with that HDMI port. I've taken the short away from it. If the pins are not connected, it's not going to make a difference. Of course, it won't display on the screen, but it will still turn on. Also, that little capacitor there, which should be down there and it's not, that would also, it wouldn't stop it from turning on. I'm not going to put any leaded solder anywhere, I'm just going to stick with what I've got here. Because I've already got some unleaded on the bottom of this chip here. Do you know, thinking about it, if the HDMI port has been changed, which it has, well maybe it blew, whatever happens to the old one, it might have blown this chip here. So the problem all along might have been this here. Obviously not when I've taken control of this, because we know that this MOSFET that I keep showing was faulty, and that's the reason it was no power on the 12 volt rail. But I think the original problem now, I'm actually starting to feel quite hopeful. I'm thinking the original problem might well have been this. Right, amazingly, I've had a little look at the pins and they all seem to be okay. So let's plug it back into the case and we'll see now, have we still got the 2-second blue light of death? I'll be honest, I'll be gutted if we have. I'll put so much work into this one. Here goes. TV's on the correct channel, but remember the HDMI port's iffy. I don't care about that, I just want to see a blue light go on for more than 2 seconds. You ready? I think it's going to work, because why was the HDMI port changed? Something's happened and it knocked the HDMI coder out. Since then it didn't work. Obviously I had to get the 12 volt rail back and stuff, but we're back to the original fault. So I think now it's going to work. You ready? Come on. Oh. Oh. Gone off again. It's no different. No, and then do it again and it will be blue light. Oh, you're so annoying. Oh, you're no different. I've put so much work into you as well. Oh, that's really, really, really disappointing. Let me just put some serious pressure down on that APU. See if that makes any difference. Right, here goes. There. No. No. Okay. Oh, I give up. I give up. It's just so weird. Like, we have this gone here, but yet there was a trace gone here. There's just weird things happening here. Do you know what I mean? And also the HDMI port. I'm pointing to this board. Obviously, it's this board down here. But, you know, HDMI ports had work done to it. Liquid metal everywhere. That was completely burnt away. We had a track there that was burnt. This thing here was shorted. It's just all very, very, very odd. And we still haven't got the 1.8 volts. And a lot of people are saying that that's Southbridge. I think that's Southbridge there. But either way, whether it's that one or that one, it's going to involve reballing, which is going to be a nightmare. I mean, you know, there's going to be hundreds of balls under that one. This isn't so bad. The balls look pretty big. But I've counted roughly 15 there, 15 there. So you're probably looking at 225 balls there. And you see, you could spend hours doing that and it still might be the APU. So I think I've taken this as far as I could have taken it. Annoyingly, this is my third PlayStation 5 and the third time I failed. So yeah, I'll tell you what I could do. Just before I finish up, should I just stick 1.8 volts into that from my bench power supply just to see if it's going to turn on? Because I don't think Gavin's going to be doing anything with this board now anyway. Let's do that as a way to end the video, just because it'd be out of curiosity, it'd be fun to put 1.8 volts in, just to see if we can fool it into turning on. Right, I've got the bench power supply here set to 1.78 volts. I'm just going to put it on the board by that capacitor where 1.8 volts should be. I want to see what it's drawing. So it is drawing something. 0.012 amps. Okay. Right, let's see if this will fool it into turning on. So let's balance it here. Here goes. And no. And again. No. I'm just going to do it as it goes to a blue light. So as the blue light comes on, I'll hit it. Come on. Nah, okay. I thought I might be able to just, you know, trick it into turning on. It would have been a nice way to finish up the video. Oh well. It is what it is. I tried my very best. If you got any enjoyment from it, give it a massive thumbs up, and I will see you all very, very soon. Hopefully my next PlayStation 5 will be more successful. Hopefully my next fix will be more successful. Thanks for watching, everyone. Take care. So just while the credits are rolling, I've just edited up this video here. It's about a month later. And when I was watching it back, I thought, I wonder now, could it be a Southbridge problem? Because we are missing the 1.8 volts. You know, that's a fact. We're definitely missing that. And also the MOSFET that blew at the beginning that was putting the short on to the PlayStation 5, it's definitely shorted one of the gates between the drain and one of the gates. It was shorted. So if it was to maybe put 12 volts from there into the gate, I wonder would that be too much for the Southbridge, and I wonder has this got a faulty Southbridge. If it has, they do look like they might be able to be replaced because the balls look quite big on them and quite spaced out, so they might not actually be a nightmare chip, but I don't know if they're married to the board. So if you think it could be a Southbridge problem, could you let me know in the comment section? If you know that the Southbridge can be lifted from a donor board and put on here, could you let me know, or does it have to be married to this board here? Do you have to swap the Southbridge and something else? Is it like Southbridge and APU that would need to come over here? If that's the case, there's no way I'm messing with that because I'm not going to go near the APU. But if it was just a Southbridge, yeah, I could possibly attempt to do that. It's not something I would look forward to, but it might be doable. I've already sunk so many hours into this, especially with the editing part of it, because it's taken me 2 days to edit. Then maybe I would spend another half day doing the Southbridge for a revisit video. So let me know what you think in the comment section below, or if you think it's the APU that's faulty, again, let me know, because then I know that I won't be looking at this again, and then Gavin can just split this up for parts, which is what he was intended on doing anyway. So yeah, I think I've been a little bit unlucky with this one. I think it's a bit of a pig of a console with lots wrong with it, and as well as that, the other thing could be faulty is the fact that it was liquid metal everywhere. Maybe there's some liquid metal underneath the Southbridge or underneath the APU which is causing a problem. I did get the data vac and just put it underneath, but the gap's about that big. There's very little airflow going to get under there, so yeah, it made no difference. Not every single video can be a success, which is a shame, but that is the way it goes. Anyway, I'll see you all very soon. Thanks for watching.